tutorial, and in this tutorial I'm going to talk about JUnit. So what is JUnit actually? JUnit is a framework for writing tests both in Java and Android, but in this tutorial we are focusing on Android applications and using Kotlin programming language. So we'll be writing tests for Android application but using Kotlin as a programming language. So furthermore, what is JUnit? JUnit, actually we use JUnit as a framework in our to write tests, because JUnit framework is responsible for how we write test, how we execute test, how we allow to configure the test, how we so you can configure your test, you can like execute your test, it will helps, this framework helps you to write the test, assert the test, and JUnit provides multiple of features such as setup and tear down, assertions, rules, runners, parameters, and orderings, matchers, and many more. But we will be discussing about this each and every concept one by one. But let's focus on creating our first test. But first, creating our test, we need to have a we need to have a code where we can for which we can write a test, right? But let me create a simple factorial class. This is a factorial class which pretty much computes factorial, and this factory is for the input n of type int, and it will return the factorial of type int. It will return the int array of passing the input and then it will just add the value 1 and then reduce and accumulate. With the accumulated value, it will just multiply with the previous number, right? So this is how the factorial works like. So and now we will write a simple test for this factorial class. To write this test, you just need to click here in your class name, then you have a suggestion, and when you click the suggestion that you will get a create a test, you just click it, and then you select your member function to test, and then finally you can 5 is not found, so it's like JUnit 4. Okay, no problem, so we can write it. Okay, and then we have to select the the folder where your unit test is gonna lie. It's unit test, and you just click OK, and yeah, so we have our this test class created, and we also have a like our function that we are gonna test okay, with the test annotation. This test annotation is really important, because if you remove this test annotation, you have you will also like this green marks will destroy. So you have to this test annotation will specify the JUnit framework that is a test class, right? So this is really important, guys. So now we will move further of writing a test for that factorial class. And how can we write that? First, we need the instance of our factorial class, right? So we have my like your factorial class. I create an instance of my factorial class, then I have to get the input which I will be passing 3, and I have a result calling my factorial class and call your factorial function, passing the input, and then finally we assert equals like the expected will be 6 as a result, and your result will be this one, right? So your expected value is this one 6, and your result is whatever result the factorial function will return passing this input. So passing the input as 3, your result will be 6 obviously, and if you run this test, you see you have a test pass 1 of 1 test, and it took 14 milliseconds to write this text, and you have this message with this green check mark. That means your test is passed. That means this is perfectly working fine, and this is our test, right? Okay, so what if I want to okay, so but the first most important thing is like the procedure or the practice that we usually do to write a test is there is a simple practice while writing a test, and you have to repeat this practice or this common pattern while writing a test or developing in your application. They are divided into three forms, which is like arrange. This arrange will in this arrangement, what we do, we initialize the inputs. Okay, so this is our arrangement. The second thing that we do is an act, and this act is where we call the method under test. So this is our act. And then finally we assert is where we verify our input our results. So you verify the results with your expected result, and you verify that your final motivation is to verify that this factorial function is pretty much giving you the right result. You know, that means your code is pretty working fine. Okay, so this is our final goal, to write a code which is less buggy as possible. Okay, so that means minimum bug as possible, and to avoid, and also the it helps you to understand your code, okay, much better. Okay, so we are pretty fine with our test, and we are pretty much fine also with our methodology, or like the pattern that we are using is arrange, act, and assert. So this is our divided into three patterns, three like types, okay, like three steps that you is used while you write your test, right? Okay, so now what if I want to not check my result with only one pattern, only one input? What if I want input of 4, I want to also check with input 5, I want to also check with input 6, and multiple inputs, you know? What if I want to do that? Is it possible in Kotlin? I mean, like, is it possible in using this JUnit framework? Yes, obviously it is possible. And obviously the one possibility is like you duplicate your code, right? You just duplicate and pass the n as 3 or 4 or whatever, like, but it will be a lot of huge duplication of the code, right? But there is a good way and the best way to write this test, and JUnit library has provided us this JUnit framework has provided us a pretty much nice runner parameterized runner class, which will run the test repeatedly for different values that we provide. And okay, let's do that. So how can we do that? Let me just go here, and let me copy the code, and I will be writing up factorial class with a parameterized test. Okay, so I'm gonna write a parameterized test. But what is the steps, what are the procedure, what is the pattern of how do we write a parameter test? Okay, the first step is obviously to use annotation run with, you are running this entire test with a parameterized class. So that means you are using a parameterized runner, okay, to run your test. And the second step is obviously you have to also declare your input and also your expected output. Private val expected is of the type int. Yeah, so this is our second step. And third, you have to create your companion object where you initialize your parameterized parameters, right? So you have a function get data. So this will be your of type collection of type array of int. it will return a list of like our parameters, and obviously to declare these parameterized parameters, you have to use the annotation parameterized parameters, and obviously you have to use JVM static because we are writing a Kotlin code where the static, the getter and setters are not necessary to be generated. But if you are using Java, obviously you need to generate that, so you can avoid JVM static if you are using Java, but in Kotlin just annotate with JVM static. And now we just pass a list of parameters that we are passing. So this is our first parameter, okay, and yeah, so if my input is 0, my expected output is 1. If my input is 1, my expected output is 1. If my input is 2, my expected output is 2. If my input is 3, my expected output will be 6. If my input is 4, my expected output will be 24. And finally, if my input is 5, my expected output will be 120, right? So this is our parameters that we are passing. And yeah, finally I have to just modify guys. Yeah, finally I have to modify my factorial, the parameterized test. Just let me rename it, and you just have actually you have not the arrangement, but you just have an act, but you're passing an input as a input from this value, and your output will be expected from here, and the result will be obviously this result. Okay, so this is our parameters test, and let me run the test now. So just guess how many tests it is gonna run. Okay, let me run, and we will check it together how many tests we are gonna. You see, actually test failed, 1 test is failed, passed 5 of 6 tests. Actually it run 6 tests, right? You see, I passed 6 parameters, 1 2 3 4 5 6, and it was able to run 6 tests, but only so sadly 1 test was failed, but we will analyze why it failed. I will just describe it. But as you can see here, using this runner parameters test class, we were able to avoid the duplication of the code and pass all the parameters that we want, and it was such a easy task, right, to write the test for multiple parameters, to test your code with your multiple parameters. And now we are exploring and understanding our code much better, because now one of the tests is failed. And why our test failed, I just will see. You see, now empty array cannot be reduced. Okay, empty array cannot be reduced. So the main problem here, why it failed, is because when your input was 0, as you can see here, when your input was 0, it failed because you cannot int array of 0, you cannot have a you cannot reduce a empty array, so empty array, int array of n, when n is 0, you cannot reduce it. So there was a bug, so we catch this bug, right? So now we will try to fix this bug. And how can we fix it? Is we can fix it by changing this code. Is we will write a fold, we will pass the initial value of 1, and yeah, we will just pass the initial value of 1. So this will pretty much initialize, instead of 0, your initial value is always 1, so now the test will work. So let me go and rerun the test after changing the code. Yes, now yes, as you can see there, test passed 6 of 6 tests, and it took 1 millisecond, very less time, to run 6 tests. You see, just one, okay, there was only 1 test was called, so 1 milliseconds to run 1 test. So actually, now the test is working fine, and we were able to fix the bug that was happening in this code, right? So this is our main motivation, is to reduce the bug in our code and understand our code much better. So now there can be multiple situations, right? Many situations, like what if I want to uh, like what if n is negative, like your input n is negative. If you pass a negative number, what if you want to handle this number, right? And the factor of input, this negative number is not handled here, right? So what if your number is too big, right? It's for example, 5 factor is 126, factor will be 120 minus so it will be much more, right? The factorial, if you say 10 factorial will be very large number, like 11 factorial will be very large number, 12 factorial will be very large number. So how can you handle these situations? So there are different scenarios. So let's go step by step. First we will try to handle the situation when your number can be negative number, right? So how can we do that? So obviously we have to change our class, right? And okay, let me write another test. Okay, let me duplicate this test and write it for factorial class negative test, right? Okay, I'm gonna write a test for a negative number. So what if my number is negative and okay, let me just run this code. Okay, let's see what's happening. And what it says, actually, the test failed, and it's a -10 negative array size exception. You see, negative array size exception, we have a exception when we try to run this test, when we pass the input as a negative number. So how to handle these scenarios in your code is we have to change our code in such a way that it will throw an exception, which is a factorial not real not found exception. But obviously this exception will also be, we have to create the class for an instance for this factorial or singleton called factorial not found exception, which will pretty much inherit from throwable throwable class, and we will just factorial not found exception and class. So it will throw factorial not found exception, and we will just pretty much say if n is a negative number, just throw the exception, throw a factorial not found exception. Otherwise you just proceed with the normal code, right? And now let's go and run this test. Still we are getting it, but to the test to handle this factorial not found exception, obviously we will have also to modify our test class, and we will say expected will be factorial not found exception if there is some kind of a exception. So let me run the test now. So now the test passed, because if there is some kind of a exception, then it will just throw this exception. Okay, so we handle in this way when there is a scenario when there is an exception, when your factorial is not found, right, for the negative number. So this is how we handle the negative number. So yeah, now let's understand and try to solve the second scenario that I discussed, were a very large factorials, right? For a very large factorial number, how can we handle it? Like for example, if my input n is okay, let me, for handling the negative factorial, I will create another test, factorial class large number. Okay, I'm trying to handle a large number test, so I will try to get a factorial of a very large number, that is 12, and try to get the try to run this test, and let's see what's the error that we are getting. Obviously you are getting a very large number. Okay, so actually this is the expected one. Okay, so now I will try to run this. Okay, we are passing, we are able to okay, it's handling to 12 factorial, but what if it's a 13 factorial? Okay, it's, this is the value. Okay, we are okay, it's also handling this this factorial, right? So what if I want a very large factorial like 25? Okay, let me run it. Expected, and actually is this one. Actually 25 factorial is a very large number, guys. Okay, so and actually, you know, like the integer that we are passing here can only hold to a certain number, like it just can hold maximum this number. The test is passing, but it is a it is not okay, it's not like it's like a false positive, you know, it's like a false positive. It's like my, the test seems like it's passing, but it's a false positive because 20 factorial is a very large number. It's gonna be a number like now actually it's getting me this result, right, of 207, but because you can handle maximum, an integer can handle maximum of these numbers, right? If I put this number and if I run this test, it is gonna run, but it's a false positive because 25 factorial is a very large number. If you see, just 14 factorial is a number greater than this one, right? 14 factorial is no, let me write is 20 factorial. No, you see 20 factorial is getting us a negative number. Obviously 25 factorial will be very large number because it is not getting like the integer cannot hold that large number. So we have to handle this situation because the test is actually giving you a false negative, you know. So in this scenario, how can we handle this very large number scenario? Is obviously by changing our class, like where we used to handle, like instead of integer we need a big integer, right? And for a big integer we have to obviously your initial will be also big integer 1. You have to return it to big integer, and this is how we try to handle a very large number, right? And now if I try to run this test, we will get a yeah, you see, we'll get this large number because now it's able to handle the input. So let me rerun the test with input n is 25. So it's a very large number, as you can see here. Actually what we get before were not a correct number, so actually this is the correct number, right? You see the value is out of range. As you see that it's a out of range value. Let's write 20 factorial. Okay. Okay. And now big integer. So we have a yes, because I have a mistake here. Because okay, it's returning a big integer. It is factor is int, and okay, so what else we can do is so we'll try to why big integer is getting expected Java long, but big integer okay, I got it guys, because we have to obviously put it inside a big integer, otherwise it's not gonna work, right? Okay, yes, now the test is passed because we have a big integer number, right? And now it's pretty working fine because we just make the slight modification in our code, because it's no more returning an integer, it's returning a big integer number, right? So this is how we solved our second scenario, where we can now handle pretty much our maximum large numbers. Okay, so uh, so now what next is let's change let's make a slight modification in our code, like instead of using this using this because actually we just care about this factor, right? Not storing all the number from 1 to n. So we can change the implementation to a simple for loop and use the test to guide us during the refactoring process. So we can now observe so actually like there is a benefit of having test in your application, and those benefits are it helps you document, it helps to understand your code, and it also helps you to refactor your code by maintaining the functionality, so, and it also helps to understand when your code breaks down or where there can be a bug. So this is the advantage of writing your test. Okay, let's update our simple code and rewrite this using simple for loop. For writing it in a for loop, I will just make a slight modification for I in 1 to n. Okay, so the result will be result times I to big integer. Actually it's doing the same thing, right? So nothing is changing. Return result. Okay, so nothing is actually changing. So if I rerun the test, obviously it should pass, and it passed. So so every test is passed even if we modify the test, right? Because we just have implement, instead of using the int array, we are just using a for loop to simplify the situations. Okay, so there are some certain situations in your test that your test will use a resource that is common to the test or the application, like databases, files, and so on. So ideally this shouldn't happen for unit tests, but there can always be exception to this. So let's analyze a scenario and see how JUnit can help us with this. So we can add a companion object. Actually, we can add a companion object in our like this factorial class, which is this result actually is pretty much added in a companion object, right? Okay, so we just modify it here, and if we run this test, rerun this test, okay, this is working fine. But what if we run this test for example this test for parameterized class? Okay, now you see that there are multiple tests failing. For example, this test is failing. Expected Java integer 1, but big integer 1 is found. Okay, so now we also have to bit modify here. Integer 1, big 1. Okay, let me just modify. And 2 is big integer value of 2, big integer value of 3 is factorial 6, big integer value of 24, and big integer value of 120. Okay, so let me rerun this test again and see what's happening here. Okay, so there are some tests which are failing. Type mismatch. Why is it happening? It's happening because obviously my expected output is a big integer. Okay, let me rerun this test again. Okay, so now actually 3 tests are failing. Okay, you run 6 tests and out of them 3 passed and 3 failed. But why these 3 failed? Because I have changed this, I have added a companion object here. Why this test is failing? So we will try to understand it much okay, so much in detail. Okay, so the test is failing because now our expected is 6, but our actual value is 12. So that means there is some kind of a value is getting actually stored, so like it's not getting cleaned up, to say, right? So we see that some tests are failing. It's because after the first test executes the factorial functions, the result will have the value of the executed test, and when the new test is executed, the result of factorial will be multiplied by the previous value of the result. So actually the value is not cleaned up, because actually we are running here 6 tests, but what is happening actually, the value of the previous test is being stored and being multiplied with the previous value of the result, right? Like it's being stored, and when you try to execute this test, also the previous value will be getting multiplied, right? So that's the situation what's happening here. Okay, so how can we solve this kind of situations? JUnit also provides us some kind of mechanism to clean up your test, it provides you to set up and tear down, right? So let's do this, right? Let's set up and let's tear down after we finish the test. After tear down the values, okay, so that the values are not saved, so so your result of factorial class dot result will should tear down, and it should be reinitialized. And when it is starting the your setup, you are also initializing with the same value, so that you will just don't have this kind of errors. Okay, so now I have modified this test with setup and tear down, right? So now let me rerun the test. You can also rerun from this button, rerun the failed test, and you see all the failed test has passed because we have done setup and tear down, so that the values of the previous test will not affect the new test. Okay, so yeah, this is what JUnit also provides. It provides two annotations like before and after for setup and tear down your test. So actually what happens is like all the before, this function is before running your test, all the functions annotated by before will be run here. So this initialization will be done here, and then only it will just execute the test. And after you finish the test, that after annotated function will call, and it will reset the value, right? So yeah, so this is it. And okay, so now let's also discuss about the different scenarios, right? So if you find yourself repeating the same statements in your before and after method, like for example, sometimes your before and after method can be repeated, right? For example, I want to also do this for this one, right? For every class I want to use the same before and after. And how can we remove the repetition? We can set up a test rule for the for this kind of scenarios to avoid a repetition. Test rules should be in the test or Android test package, as their usage is only limited to testing. They tend to be used in multiple tests, so you can place your rules in a rules package. Okay, so let's create a let's create our rules, right? Let's create a package called rules, and let's create a class which will be pretty much called a result rule, and which will extend a test rule, and apply will override the apply function. We have a basic statement and description as a parameters, and what it does, it returns the object statement, and we actually we have to override implement a evaluate method, and we throws a throwable class. And finally what it will do is your class is like a factorial class dot result will have a big integer as a 1, which is initialized, and try using base dot evaluate, and finally it will also do the same thing, right? So it's pretty much doing the same thing like before and after, right? Initial setup and tear down. So you have an initial setup and final tear down, so this is the test rule. This is how we write the test rule, and finally we can implement this test rule in our class. Okay, and how can we write that, implement that test rule is field rule result rule, it will be result rule that we have just entered. Let's try to avoid this scenario of setup and tear down. Okay, and yeah, we don't so we use this rule annotation to add the rule to our test. And as you know that since we are have used the writing test in Kotlin, so we use this JVM field so that no extra getter and setters will be generated to say yeah, just to avoid the generation of getter and setter. And so rules require a public method, a public field, not a method. Okay, so this is what it is. And yeah, that's it guys, this is how we write the rule of the test. Okay, and yeah, the test is pretty much working fine, and the rule is working fine, and everything is working fine. So we have learned a lot of interesting things about JUnit framework for writing tests. Hope this tutorial will be very helpful for you guys. And yeah, if you like it, please do subscribe and help me guys, so that I'll be coming with more and more tutorials like this. And please also click the bell icon, so that you will get notified with any new releases or new videos that we'll be uploading. And thank you very much, and catch you up in the next lecture guys. Thank you.